more specifically Nathan, and Anote is a startup that aims to make AI more accessible. They integrate AI models with human feedback to customize them for specific use cases and industries, making AI more practical and user-friendly. So this was a really amazing privilege to be able to work with them to apply the skills that we've learned throughout Breakthrough Tech AI. And so for introductions, my name is Fatima and I go to Hunter College. I'm majoring in computer science and economics.
Hi everyone, my name is Spurti Sethi. I'm currently a sophomore studying software engineering at Stevens Institute of Technology.
Hi everyone, I'm Eden. I'm a sophomore at Barnard at Columbia and I'm studying computer science.
And in our project, we've also worked with the amazing Sakshi Pandey. Shout out to you. She was a really great support in helping us organize and work on our project, and our challenge advisor and the Chief Executive Officer of Anote, Nathan Vidra. So thank you so much. And in our presentation, we will be starting off by an overview of the project's objectives and relevance, and then we will go into a discussion of how the project aligns with the business goals and objectives of Anote. And we will also go through the data collection and pre-processing process by giving an explanation of the data sources used in the process and how the data was used for analysis and any challenges that we faced. We will also go into the model development and methods by giving a presentation of our live website. We created a Streamlit app so that you can interact with our language learning model. We also give an overview of any algorithms or tools that we use. And we will end off our presentation by giving an assessment of the model's performance and effectiveness, and a discussion of our key findings and the lessons that we've learned, and an outline of potential next steps and improvements that can be made. So in our projects, we aim to create a domain-specific language learning model that can answer questions about 10K documents. For reference, a language learning model is a type of artificial intelligence model that is designed to understand, interpret, and generate human-like language. These models are trained on large data sets in order to understand the patterns within the data. And in our project, we developed a specialized language learning model to outperform general models like GPT in understanding and responding to 10K financial data. We aimed to make the work of human analysts more efficient by minimizing the need for manual annotation and data extraction. Automating the analysis of 10Ks can lead to cost savings because it reduces the need for extensive manual labor in reviewing and extracting information from financial reports. We refined our model by providing it with specific context and additional information, which helps prevent inaccurate or hallucinated responses, which refers to when a model generates information that is incorrect or doesn't align with reality. By reducing these hallucinations, we ultimately improve the model's overall accuracy. In simpler terms, we're creating a smart tool that helps financial experts quickly and accurately analyze complex documents, reducing their workload.
So going more specifically into the business impact of why a product like this would be useful to several different people. So to go over what exactly a 10K is, so a 10K is an annual report that every publicly traded company is required to publish to the SEC. And this report, it's obviously very long and extensive, 100 to 200 pages long, but it provides a very comprehensive overview of that company's business models and several different information, as well as detailed information of the company's finances and specific like accounting and financial statements, as well as analysis of these like financial statements and various other factors of the company. And there's a lot of valuable information that can be found in this 10K, such as what risk factors is this company exposed to, or even just evaluating the the financial health of that company via these financial statements. So until this time, we would have to have people like financial analysts to tediously look this information up, whether they're investors or stakeholders. You had to have a lot of like dozens of analysts manually go through these documents in order to get the desired information. However, this is extremely tedious, time consuming, and not the best use of these people's time. So by developing a large language model for the specific use case, it enables these people to automate a lot of that process that can save them a lot of time, money, and allow these parties to get the desired information that they need a lot more quickly and easily. And to go over the approach of how we approached this project over the course of the semester was that when we first was given this project at around August, we first focused on the data collection of how exactly we get these 10K documents, and we first a little with prompt engineering. So how can we ask these questions to like the models already out there, like GPT, and then transitioning into the next months, we experimented and implemented with more sophisticated techniques such as retrieval augmented generation, or RAG for short, and then transitioning into fine tuning to make our model even more specific. And then towards the end, we integrated these models together and then worked on evaluating it, as well as developing a front end for easy user interface and interaction. And we used a variety of different resources. So most of the work we did was in Python, and we used a lot of Jupyter notebooks for that. And in terms of like more specific Python libraries for this work, LangChain was used pretty extensively. It's a framework very commonly used for LLMs, and within LangChain, we used a lot of its specific modules for parsing unstructured data. And we'll go more specifically, but while we were doing RAG, we utilized things like ChromaDB and Pinecone, which are two different types of vector database. So the large language model we ended up using was GPT. So we utilized OpenAI's library and packages for that. And then we used Streamlit for the front end. And we'll go into more specifics of how we specifically use these libraries for our model when we go into more specifics.
So now I'll talk a little bit about like the data understanding and the data preparation. So to start with the data collection, our raw data were, as we said, these 10K documents. Here's an example of Apple's 10K. So this is the front page. They are usually 100 to 200 page documents. So we have these in two forms, either in PDFs. So users will have it locally downloaded on their computer as a file, or as an XML file, which is accessed via an API, which means as the user, you just have to enter the ticker. So for example, AAPL, and then it'll automatically access the document for you in this form called an XML file. This data is collected in a very unstructured format. So each 10K can be in very different format. It's not very standardized. And so we have to do some data processing afterwards. So for the processing, we use several libraries first to read the information from the document and process it. So we use unstructured.io, PyPDF. Then from there, we would split up the large 200-page document into chunks, which is like, you could think of it as like separate paragraphs. So we use LangChain and TextSplitter for that. And then once we had these chunks, in order for the computer to understand it better, we have to convert these words into numerical representations. So this is called embeddings. So we use OpenAI embeddings and Hugging Face.
So going into how we actually started developing our model, the first step we did was retrieval augmented generation, or RAG. And this graphic right here describes the overall architecture of how something like this works. So the user would give in their query, for example, what was the revenue of this company last year? And while the large language model on its own may not have that specific information, what it'll go do is that it'll take that query and then it'll search relevant information based on the words in that query from the knowledge sources. And these knowledge sources are going to be our 10K documents. And the way it finds the relevant information is through a vector similarity search. So when these large language models work is that many of the texts are tokenized and made into something called embeddings, which are like numerical representations of the words. So through mathematically comparing them, it can find the most relevant words and the sections of the documents, and then it'll feed that enhanced context, which is the relevant sections in the knowledge source, back into the large language model, so that now when you ask its question, it won't only have the question, what is the revenue of this company last year, it'll also have the section of the 10K that actually talks about the revenue and the income of the company. So it'll have the additional context, which hopefully will have the answer hidden in it somewhere. And that's giving the large language model the ability to answer it more accurately and mitigate the probability of having hallucinations. And we used ChromaDB, which is a local vector database, as opposed to Pinecone, which is a database stored in the cloud, just because of limitations of indexing, and also for a future, if we wanted to make something fully local, we thought Chroma would be the best way to do that.
So after using RAG, we then had to do fine-tuning. So because we were trying to create an improved model upon the existing GPT model, we had to fine-tune it to improve it. So in order to fine-tune it, we had to create a training set with some different data points. So we had around 40 different data points, and each of them has these three components. So system, instructions, so we're telling it it's a chatbot that answers questions. And then we include both the questions. So for example, what was the company's revenue in 2023? And then using RAG, we would get the most relevant chunk, so like the most relevant paragraph. We would include that, and then we would come up with an answer that we give it. And this answer would be what we think is the ideal answer and what we would want the model to return to us in the future. So this was pretty challenging. Here was one of our biggest challenges because this field is so new. There was not a lot of information available. So we had to do quite a lot of research and look at the OpenAI documentation in order to understand how to fine tune it and the best way to go forward.
Yes, so now that Berthy and Eden have explained, we've used drag and fine-tuning to build our model. And our fine-tuning was facilitated by OpenAI's latest model, GPT 3.5 Turbo. We've also developed a user interface enabling input of either a PDF document or a company ticker, such as AAPL. A company's ticker is a unique series of letters assigned to its publicly traded shares in the stock exchange. It serves as the shorthand identifier of a company and is commonly used in financial markets. So now we will be providing a short demo of our app. Yes. So as you can see, we use the Edgar API, which offers a centralized and structured repository of financial documents, including 10K reports. And these documents contain essential financial information, business strategies, risk factors, and other details crucial for understanding a company's financial health and operations. Here I input a ticker and I was able to ask a question. Our app also does error checking. If you were viewing the demo earlier, you saw that when I did not input a ticker, it gave me an error to input a ticker before I asked a question. So that is one of the benefits of using Streamlit. Streamlit offers a straightforward and intuitive approach to building web applications with minimal code. You can create an interactive chatbot interface, reducing development time and complexity. As you can see, I asked it a question and I was able to ask it a follow-up question to specify or give me more information regarding the previous question. And one of the areas where app lacks is that it is a bit slow. However, um, it, it using Streamlit was able to benefit us because we were able to use widgets like text inputs and chat messages, which let us easily capture user input and display responses, creating a seamless conversational experience for the chatbot users. And Streamlit also effortlessly integrates with machine learning models. So the AI chatbot leverages capability to provide context-aware responses based on the analysis of the 10Ks. And sorry, I know it's a bit slow, but you can ask it multiple questions and it will save the user's history because of the session state feature in Streamlit, which enables the preservation of information across user interactions. This is crucial for maintaining the context of the conversation, ensuring a coherent and meaningful dialogue with the chatbots. And there is also a live reloading feature in Streamlit, which allows for real-time updates, enabling a responsive user interface. Being an open source project, Streamlit benefits from an active community. The extensive documentation and community support make it easier to troubleshoot and explore features for our AI chatbots.
Okay, so now I'll do a quick comparison of what the model is like before and after fine-tuning. So for example, given a question, are there any significant trends or patterns in the company's financial statements? GPT's answer before fine-tuning gave us an answer. This 10K document does not explicitly mention any significant trends or patterns. But our model gave us an answer showing the revenue across 3 years, so 36 billion, 20 billion, 18 billion, and its income 16, 11, and 6.5. So we can see in this example that GPT was unable to find an answer from this document, but our model was able to give a pretty comprehensive answer. Now we'll discuss a little bit the evaluation of our model. So what we chose to do was just a right or wrong method. So we asked 15 more questions upon 3 new 10Ks, Dropbox, Google, and Netflix. And for each of these questions, we would ask the question to the fine-tuned model and the normal pre-fine-tuned model. And then based on the answers that we thought were, we gave our answers that we thought would be the correct answers, and we would determine whether the model matched the answer that we gave or not. So we decided to do this approach because another approach that we considered was doing a similarity search between the answers. So I can just give a quick example. So for example, if the ideal answer is the company's revenue was 334 million in 2023, if we have sample answer 1 being the company's revenue was 1 million in 2023, as we can see, that's incorrect because it says 1 million versus 334 million. And then sample answer 2 says in the year 2023, Apple had a revenue of 334 million. So this answer is correct, but worded slightly differently. And if we could use the similarity search, it would place answer 1 above answer 2, just because the textual format matches more closely, even though the actual key information is incorrect. So that's why we decided to just manually look at the information and determine ourselves whether it was right or wrong. And overall, the pre-fine-tuned model had a 58% accuracy, and the fine-tuned model had a 64% accuracy. So we managed to have an increase of 6%. And some of the questions that our fine-tuned model got wrong, so like question 3, question 8, question 9, question 10, for example, looking back at the fine-tuning data, the training set, it was clear that these questions were the ones that had the weakest training data. So If we had better training data, we could increase the accuracy a lot more.
So now transitioning into concluding thoughts and some of the main challenges we face in our model and how we can improve upon that in the future. So first off is the data complexity of simply speaking of the nature of 10Ks. They're very complex documents in terms of how long they are. They often use very sophisticated financial and legal terminology, as well as the complexity of the actual structure, because you'll have different headers and then white space with different sections, and it's not only text. Some of these also documents often has like tables and charts of the financial data. So overall, the nature of the data is pretty unstructured and complex. So in order to combat this in a better way, perhaps we can integrate like name entity recognition, which is, on a simplistic term, you can think of the model being able to identify, okay, this is, a noun, a verb, or a place, but a more sophisticated version for our model, so it could better identify these are different companies, or this is what this financial term or key term means, as well as like for specific legal jargon as well. And then also this goes into improving the training data and make it more customizable. Expanding off of what Eden was saying, a huge bottleneck for our project and model was the availability of training data, as we had to since our model is a question answering bot, it needed ideal answers for question and answers. And we had to develop those data points on our own, which was very tedious, and you can't scale that very easily, as well as we don't know how well the quality of our answers are, since we are not financial experts on our own. So a really interesting avenue to go down in the future would be actually collaborating with financial experts and getting available data for high quality question and answers that we want to model our model after to make a more robust large language model. And then so we use another point was to experiment more with different large language models. GPT is kind of more the mainstream one, and that's the one we ended up integrating, but there's several others out there that have been published by several large companies as well. So Llama is another one that was by Meta, and actually we had got a version of this model working with Llama as well. However, it just was a lot like slower and more cumbersome, so we stuck with GPT. But with more like time, it would be interesting to explore the different strengths and weaknesses of these different large language models other than GPT, and evaluate the pros and cons of each model, and then decide which one would be best for our use case. And then the final point was, in order to like optimize performance on our model, as you kind of like saw a little bit in the demo, it could be a lot faster, and for practical applications, it would be annoying to have to wait, like even if it's just a minute or two to get answers. And like when I like run the Llama ones before, it would take several minutes for every response. So there's several different avenues we can go down in order to optimize the performance in terms of speed and efficiency. So if we're running local models, we can try to use GPUs, which are better for parallel computation as opposed to traditional CPUs. We could also do more experimentation to selecting an optimum model size. So GPT obviously and a lot of these models has billions of parameters, but so there's a trade-off with having a larger, more complex model could perform better for more complex and nuanced tasks that we have to do here. However, perhaps not as large of a model is needed, especially if we can go into more specifics into customizing the training. And then also as a final point, integrating more robust like data caching. So for example, the model, it would recognize frequently asked questions and be able to cache them to like reduce the amount of redundant API calls, or even if it's a local model, just getting getting that data from the drive. So these are kind of the different avenues of challenges we identify and potential next steps. But overall, this was a lot of ours like first kind of experience in doing those things. So it was pretty good a starting point, and I think we've done a lot over the course of the semester, but there's obviously a lot of room for improvement to make it a lot better. And that sort of concludes the presentation we have for our Breakthrough Tech Final AI Studio project. Does anyone have any questions?